Okay, for the last couple of days, we have been working on finding the line of best fit and the curve of best fit. Now, it's really important that we know how to recognize which one we're dealing with and that we also know the equations for these different things. So on a line of best fit, you need to remember that the graph will be a straight line. On the curve of best fit, you'll get that U-shaped graph. It's a quadratic graph. For a line of best fit, your equation is going to be y equals mx plus b. And for the curve of best fit, it's going to be y equals ax squared plus bx plus c. Now, don't forget that when we type those two equations into Desmos, there are some changes that have to be made. The y and the x get 1s on them, so it's going to be y1 and then mx1 plus b. And then our equal sign becomes that little squiggle mark. So here is how I would type it into my calculator. Over here, my y becomes a y1. I have ax1 squared plus bx1 plus c. So the x's and y's all get 1s, and then your equal sign becomes a squiggle. So here's what I would type into my calculator. So line of best fit, curve of best fit. Now, we're going to continue to work on this today, but the problems are going to ask us to take an extra step. They are going to ask us to make predictions. So I'm going to be showing you in this video how to do that. All right, so here's our first example. Whoops. So here's our first example. In this example, it says the value V of a computer between 1999 and 2003 is given in the table below. Write an equation for the line of best fit, then predict the value of the computer in 2008. So you'll notice here that just like we've been doing for the last couple of days, it asks us to find the equation of the line of best fit. But then notice this extra statement out here. It asks us to predict the value of the computer in the year 2008. So that's the prediction part of this. Now, you'll notice your table here is labeled with the variables T and V. T stands for the year, and V stands for the value of the computer. You need, since this problem is a line of best fit problem, you need to think of those in terms of x's and y's. So the years are going to be our x's and the y's are going to be the values. So coming over here to Desmos, the first thing I want to do is put this table into my Desmos calculator. So I'll hit my plus sign and choose table. Now my x's are going to be these years. So I'm going to type in 1999, 2000, 2001, 2002, 2003. And then over here in my Y column, I'll put the values of the computers. So 800, 720, 640, 572, and 480. All right, so I have my table entered into the computer. Now, one thing you'll notice that's different is you can't see the graph over here. And that's because these numbers in my table are much larger than I'm able to see over here on my graph. Now we do have the option of zooming in or zooming out, so I could zoom out. But you'll notice the graph is not a lot of help because these points all seem to land right on top of each other. So it doesn't really let me see what I need to see. So I will tell you on these prediction problems that the graphs are not going to be a tremendous amount of use to you. So here's what we're going to do. Looking at the problem, you will notice that they told you. They want you to write the equation for the line of best fit. Now the line of best fit is y equals mx plus b. But in my calculator, I know I'll have to make that y1 squiggle mx1 plus b. So I'm going to come over here and type that in. So y1 squiggle mx1 plus b. I get that my m is negative 78.8 and that my b is 158,321. So we will come over here now and plug that in. So we get y equals, and it's going to be negative 78.8x plus 158,321. All right, so that is the equation for my line of best fit. Now, I'm not done with this problem because it said to predict the value of the computer in the year 2008. So 2008 would be right here. And then I'm looking for the value of the computer. So right there's what I'm trying to find. So notice 2008 would be an x value. So I'm going to plug that into this equation right here. So I get y equals negative 78.8 times 2008 plus 158,321. So on the prediction part, you're going to take the number they've given you and just plug it into that equation that you have. All right, so I'm going to delete what I have over here. And right here, we're going to do negative 78.8 times 2008 plus 158,321.
91 minus 91.
And you'll see here your answer of 90.6. So that would be the value of the computer. So if we think about it, when the computer was purchased in 1999, it was worth $800. In the year 2000, that had dropped to 720. 2001 was at 640. 2002, $572. 2003, $480. In 2008, which is 5 years after this right here, that's going to be down to $90.60, which is reasonable. That makes sense. At the rate the value of the computer is dropping, that if 5 more years pass, it's going to be down to that much. So you're finding your line of best fit just like we've been doing, but then you're making that prediction for the second part of the problem. All right, so here's another one. This one says that a coin is thrown off the top of the Statue of Liberty, which is 305 feet from the ground. The height h of the coin is recorded after each second t in the table below. Write an equation for the curve of best fit, then predict the height of the coin after 7 seconds. So here are your times. At 0 seconds, the coin is 305 feet above the ground. At 1 second, it's 367 feet above the ground. At 2 seconds, 397 feet. At 3 seconds, 395 feet. And at 4 seconds, 361 feet. So we want to do a curve of best fit and then predict the height of the coin after 7 seconds have passed. So in our table, at 7 seconds, we want to figure out what number would be over here. All right, so our first goal is going to be
134, bus 134, bus 81, bus 81.
okay, so as I was saying, the first goal is going to be to put this table into the calculator and come up with the curve of best fit. Now, curve of best fit is that quadratic equation. So it's going to be y equals ax squared plus bx plus c, which we will enter as y1 squiggle ax1 squared plus bx1 plus c. All right, so let's come over here and do this. We'll hit our plus sign in our table, and we'll enter our numbers. So we have 0, 1, 2, 3, and 4. Then we have 305, 367, 397, 395, and 361. So there's my table. I'm going to do y1 squiggle ax1 squared, so I have to hit my a squared button, plus bx1 plus c. And then if I come over here and look, there are my numbers right there, A, B, and C. So my curve of best fit is y equals negative 16x squared plus 78x plus 305. So right there is your equation for your curve of best fit using the numbers your calculator provided. Now we're not done yet because they wanted me to predict the height of the coin after 7 seconds. 7 seconds is a time, and that is in the first column of my table, so that makes this an x value. So we're going to plug the 7 in for the x's over here. So you're going to get y equals negative 16 times 7 squared plus 78 times 7 plus 305. And then all I have to do is use my calculator to get this answer. So we're going to do negative 16 times 7 squared, so I'm going to hit my a squared button, plus 78 times 7 plus 305. My answer is 67, which means that after 7 seconds have passed, my coin is going to be 67 feet away from hitting the ground. Now, what you may notice here is it talks about the Statue of Liberty, the top of the Statue of Liberty being 305 feet from the ground. So you'll notice the coin starts out 305 feet from the ground. And then what you should notice is the height goes up and then starts to come back down. The reason for that is if this line represents the Statue of Liberty and I'm standing here throwing that coin off, I'm not going to throw it, well, get out of my way just a minute here. I'm not going to throw that coin straight down. What's going to happen is when you throw it, it's going to go up at first and then start to fall towards the ground. So that's why 305 is your first height, and then it goes up and then starts to come back down. So after 7 seconds, your coin is going to be along in here, 67 feet away from the ground. So do the line of best fit or curve of best fit, and it will tell you in the problem which it is. Do that first and get that equation. And then they're going to give you a number that has to be plugged into that equation so that you can make your prediction. If there are any questions about this lesson at all, please feel free to email me and let me know.